Welcome to a new arc, the Recurrence, where the past is just a preview, only on your dose of Wowness.
In 1912, a German meteorologist stood in front of a room of geologists and proposed something that, to nearly everyone listening, sounded less like science and more like a party trick. He pointed out that the coastlines of South America and Africa fit together like torn pieces of paper. He backed it up with matching fossils found on both sides of an ocean that, according to every geologist in the room, had never been crossable by the animals in question. And he proposed that the continents themselves had once been joined and were still, slowly, drifting apart. His name was Alfred Wegener. His idea was continental drift, and the geological establishment rejected it. Not once, twice. First in the 1920s, most viciously at a symposium organized specifically to take his theory apart piece by piece, and then again for another 3 decades as a fringe idea most working geologists simply didn't take seriously. The people rejecting Wegener had a legitimate scientific point. His evidence for continents moving was genuinely strong. His explanation for how they moved was genuinely wrong, and it would take more than 50 years and an entirely different kind of evidence pulled from the bottom of the ocean to finally combine the two. This is day 138 of your dose of Wowness, continuing the recurrence. Today's pattern: a correct idea, rejected, rejected again, and finally vindicated only once science found the piece Wegener himself never had. To understand why the room reacted the way it did, we have to look at what geologists actually believed in the early 20th century. There was a strict consensus that Earth's land masses were entirely static. The ground you stood on was exactly where it had always been since the crust cooled. Wegener wasn't trained in that consensus. He was primarily an atmospheric scientist, with a reputation for demanding polar fieldwork in Greenland, tracking ice cap dynamics and weather patterns. He was used to looking at global systems from the top down. This background allowed him to comfortably synthesize findings from paleontology, climatology, and geodesy, integrating data that a specialized field geologist would rarely combine. But it also meant he lacked the institutional standing to propose a massive reordering of the Earth. To the establishment, he was a weatherman trying to rewrite geology. Yet the evidence he brought to the table was incredibly stubborn. Take the Mesosaurus. We find its fossils in identical rock formations of the exact same age in South America and Southern Africa. The problem? Mesosaurus was a small, freshwater aquatic reptile. It had absolutely no physiological way to survive a crossing of the saltwater Atlantic Ocean. Or look at Glossopterus, an ancient seed fern. Its fossils show up in matching geological strata across South America, Africa, India, Australia, and Antarctica. These land masses are separated by thousands of kilometers of open ocean and sit in completely different climate zones today. Facing this biological and geological correlation, Wegener reached a logical conclusion. Those species never crossed an ocean. The continents themselves had to have been joined together into a single, massive supercontinent he called Pangaea. Then came the fatal flaw. When pressed on how these massive continents actually drifted apart, Wegener proposed they were physically plowing through the solid rock of the ocean floor, driven by Earth's rotational centrifugal forces and the gravitational pull of lunar tides. This created a scientific stalemate. Wegener had assembled observational data that practically demanded the continents had moved. But to make them move, his proposed engine violated the known laws of physics. The tension boiled over in November 1926. The American Association of Petroleum Geologists convened a symposium in New York specifically to evaluate Wegener's theory. These were practical men who demanded observable mechanics, and the tone they took was openly hostile. They brought the math. Prominent physicists like Harold Jeffreys calculated the force generated by lunar tides in Earth's rotation, proving those forces were millions of times too weak to drag a continent through oceanic crust. Furthermore, the geologists pointed out a glaring physical contradiction. If continents genuinely operated like icebreakers plowing through solid ocean crust, the leading edges of those landmasses should exhibit massive, catastrophic crumpling. We don't see that kind of overwhelming deformation on stable coastlines. Wegener died on a Greenland expedition in 1930. He spent the last 2 decades of his life defending a brilliant compilation of fossil correlations, But he never solved the mathematical impossibility of his mechanical engine. It is tempting to look back and view the 1926 Symposium as a room of closed-minded academics trying to destroy a visionary. But the reality is that their rejection was a rigorous, legitimate defense of the scientific method. You cannot accept a theory built on a physically impossible engine. Following the Symposium and Wegener's death, continental drift entered a long, quiet winter. For the next 30 years, the mainstream scientific establishment largely dismissed it as a fringe position. Working geologists in the Southern Hemisphere continued to find even more matching rock strata and fossils linking South America and Africa throughout the 1930s. The observational evidence was only getting stronger, yet the Northern establishment remained completely unmoved. And they were justified in waiting. A mountain of perfectly correlated leaf and reptile fossils could not magically generate the physical force required to push a continent through solid rock. Two correct scientific instincts were trapped in an unresolved tension. Wegener's observational biology told a true story about the past, while the establishment's rigorous physical mechanics maintained a necessary standard of proof in the present. The breakthrough finally arrived in the mid-20th century from a completely different direction. Researchers studying ancient paleomagnetism discovered that rocks were recording the orientation of Earth's magnetic field as they formed. When compared globally, these magnetic records proved the ground itself had genuinely shifted position over time. Drawn by geologist Harry Hess around 1960, this chalkboard diagram maps his seafloor-spreading hypothesis, revealing the missing engine. Continents don't plow through the ocean floor. Instead, new crust is created by magma at mid-ocean ridges, spreading outward like a conveyor belt carrying the continental plates. In 1963, geophysicists confirmed Hess's hypothesis by finding symmetrical, alternating bands of magnetic polarity striped across the ocean floor, running exactly parallel to the mid-ocean ridges. It was direct, measurable physical confirmation that the seafloor was spreading apart. Wegener's 50-year-old biological correlation was integrated into Hess's mechanical engine, forming the modern theory of plate tectonics. The vindication of continental drift didn't happen because one side beat the other. It happened because science required Wegener's visionary ability to leap across disciplines and the establishment's uncompromising demand for physical, mathematical proof. This is the heart of the recurrence. A substantive truth was rejected twice because it lacked a crucial component, languishing for decades until a separate discipline provided the physical mechanism required to complete the theory. If you like your Monday with a side of the scientific establishment was both right and wrong at the same time, hit subscribe. Tomorrow, for day 139, we zoom all the way out with Empires on a Timer, looking at a controversial modern attempt to model societal instability mathematically, and asking if human history really does run on cycles predictable enough to chart in advance.
Thank you for sharing this moment of pure wonder. You are the true magic that fuels this journey. Until next time, remember to shine bright.